Analogy. The radical is the square root sign itself. So when you see the term radical, they are talking about the square root sign itself. So your first step when you have radicals that you are multiplying, you're going to multiply any numbers that are outside of the radical. And then you are going to multiply the radicand. The radicand is the number under the radical sign. So under that radical sign is the radicand. That's the number inside. So you have numbers outside, you have numbers inside, and then you are going to multiply those individually. Once you do that, then you will simplify the radical. So you will see different types of instructions. Some instructions will say write in simplest radical form, and some will say round to the nearest whatever, 10th, okay? And so those are the two answer types you're going to be looking for. If it says simplest radical, then you're not just going to plug it in your calculator, you're going to actually simplify it, which is what we're about to do. So let's look at this first example, this sample here. They have 5 squared root of 2 times 3 squared root of 6. We're going to multiply the outside numbers, which are 5 and 3, giving us a 15. All right? Then we are going to multiply the inside numbers, the 2 and 6, giving us a 12. This is where we got the 15 here and the 12 here. This is not simplified. That 12 on the inside, we need to check to see if we can make that any simpler, and we're going to use prime factorization to do it, also called a factor tree, depending on how you learned it. So we're going to take that 12 and we are going to factor it. I always use on the left-hand side my smallest prime so that I don't lose them inside my radicals, inside my factor tree. So I'm going to say 2 times 6 and 2 times 3. When all of those numbers are as simple as they can be, you are done. And you can always check it. You can say, does 2 times 3 equal 12? Yes, it does. I factored it correctly. All right? Now that I factored it, if it pairs up, it comes out of the radical. If it does not pair up, it stays in. Okay? So I am going to take my pair, which is the 2 and 2, pair up. They go out. So my 2 comes out of the radical. My 3 does not have a pair. It stays in. So my 3 is staying in the radical. I already had a number out here. The 15 is going to be multiplied by whatever I took out. So my final answer here, when it is completely in simplest form, is going to be the 15 times 2, 30, square root of 3. 30 square root of 3. So you need to be very familiar with factoring. All right, you're just breaking it up into prime factors, meaning they're prime numbers, you can't break them up anymore. Prime number can only be divided by itself, and composite numbers can be divided by other numbers. Okay, so we're going way back to the basics of prime versus composite, which is like 4th, 5th grade, somewhere in there. Okay. Numbers outside of the radicals can be divided. Numbers inside the radicals can be divided. And then you are going to simplify. You cannot divide from outside to inside. So you cannot simplify one on the outside and one on the inside. All right? Let's look at this example here. They have 18 squared root of 10 over 3 squared root of 2. I can simplify the 18 and the 3. I can simplify the 10 and the 2. I cannot simplify the 18 and the 2. Okay? Only outside to outside, inside to inside. So I am going to look and see, can I simplify this? Yes, I can. Can I simplify this? Dividing the inside? Yes, I can. So that means my 6 was on the outside. My 5 was on the inside. I will always check to see if I can simplify the inside. 5 is already a prime number. The only numbers that go into it are 1 and 5, which means I cannot take anything out. Had it been 15, the only numbers that go into 15 are 3 and 5. Nothing pairs up. I cannot simplify the 15. The only time you can simplify it is if you have a pair of numbers that can come out, okay? A pair of numbers that can come out. So this is as simple as it gets. This is your answer. You can never, ever, ever have a radical in the denominator. So you do not want to leave it with a radical. This is actually really important for standardized tests, by the way. Because on a standardized test, if you get an answer and you don't recognize that they just simplified it, you could potentially get the wrong answer. So it's always good to recognize your answers on a multiple choice test, like a standardized test, okay? This process is called rationalizing. We are going to rationalize the denominator here. So you're going to take that denominator and you're going to multiply top and bottom by that denominator to get rid of it. So if I have something like the square root of 2 over the square root of 3, the process here is to multiply the top and the bottom by the square root of 3. Just a reminder, when you are multiplying radicals, we just did it, you just multiply the insides. So in that numerator, I'm going to get 2 times 3, which is the square root of 6. In the denominator, I'm going to get square root of 3 times square root of 3, which is the square root of 9. That can be simplified. What is the square root of 9? 3. You will notice when you multiply radicals by themselves, the radical just goes away and you are left with what's inside. So what do I mean by that? Well, if I multiply square root of 5 times square root of 5, my answer is going to be just 5 because it's the square root of 25. If I multiply the square root of 7 times the square root of 7, my answer is going to be just 7 because it's the square root of 49. Some of you had this on your review sheet and you did not know how to do it because you were doing Pythagorean Theorem and it had a radical, right? If you have the Pythagorean Theorem and you have a radical there, all you're going to do, a squared plus b squared, and when you get to that radical squared, your radical just goes away. It is just 170, okay? And so some of you did not know how to manipulate the radicals in your Pythagorean Theorem. It's because you're not remembering your rules here, all right? So I want y'all to try a few of those, then we're going to get to special right triangles.